Hello, welcome again. We are solving some questions of heat transfer. The topic is one dimensional heat conduction. Question number 31 and 32 are the shell of an experimental boiling water reactor is cylindrical, having inner inside radius 1 meter, length 1.25 meter, and 10 centimeter wall thickness. The shell is made of alloy steel and a concrete wall 50 centimeter thick surround it. The inner wall temperature at R1 is 150 degrees. Okay. And R1 is 1 meter, R2 is 1.1 meter, R3 is 1.6 meter, K alloy steel is 22.5 watt per meter per degree Kelvin, and K concrete is 1.12 watt per meter per degree Kelvin. If the heat loss through the reactor is 240 watt, then question number 31, the temperature at outside surface of concrete is option A 139.65 degrees Celsius, option B 149.65 degrees Celsius, option C 140.1 degrees Celsius, option D 135.6 degrees Celsius. Question number 32, the temperature of interface concrete and alloy steel is option A 139.65 degrees Celsius, option B 149.65 degrees Celsius, option D 140.1 degrees Celsius, and option C 140.1 degrees Celsius, and option D 135.6 degrees Celsius. So R1 here is 1 meter and R2 is your 1.1 meter and R3 is your 1.6 meter. KS is 22.5 watt per meter degree and KC is 1.12 watt per meter degree. And heat loss through the reactor is 240 watt. So thermal resistance due to cylindrical wall is general formula is ln R naught by Re divided by 2 pi Ks. Okay. So first of all, taking this alloy steel, alloy steel, and for this resistance is R2 is 1.1, R1 is 1, and 2 pi, and that is 22.5, K is 22.5, and L is 1.25. So RS comes out as 5.396 in 10 power minus 4 degree per watt. Okay. And similarly, resistance due to concrete covering, this concrete covering is log 1.6 divided by 1.1, 1.6 divided by 1, because this outer radius is 1.6 and this inner radius is 1.1, and divided by 2 pi. K is conductivity of concrete and L is 1.25. So RC is 426 minus 4 degree per watt. Okay, so total resistance is summation of these two, and it will be 431.964 minus 4 degree per watt. Okay, so in terms of resistance and temperature drop, the heat transfer is given as Q delta T by RT. RT we have found out, and delta T is inner temperature is given as 150 and outer temperature is 4T3. So heat transfer is given as 240. So putting that 150 and this as T3, 151 T3 temperature divided by 431. So T3 comes out as 139.65 degrees Celsius. Okay. So now this temperature is 135.65 degrees Celsius. Okay. And second question is, we have to find out the temperature at interface. Okay, that at interface. So temperature at interface is 42 and heat transfer is 240. So that is from this we can find out by putting that resistance only, resistance of the steel. Because here when we take the temperature difference from this to this, we will take total resistance. When we take temperature difference from this to this, we will take the alloy steel resistance. So taking the alloy steel resistance, so T2 will be your 149.87 degrees Celsius. So answer to question number 31 is A and 32 is B.